For part D, we have a cobalt/cobalt chloride equilibrium. The COH2O6 2+ ion is originally a pink color, while the COCl4 2- ion is originally a blue color. So when HCl is added to the cobalt chloride solution, more Cl ions are reacting, which causes an increase in them, which again, that's right here, which therefore causes the equilibrium to shift right. This therefore creates a more purple color, so you can tell that the equilibrium is shifted right because an increase of the COCl4 2-, which is the blue color, you can tell because the color is changing towards that. When heat is added to the cobalt chloride solution plus HCl, the reaction is endothermic, which also shifts right. So as heat is added, the equilibrium turns a dark blue color, which again corresponds to an increase of the COCl4 2-, which means that the equilibrium is shifting right because the equilibrium is moving towards the COCl4 2-, creating the blue color. And then whenever cold is added, the reaction goes back to a pink color, which we can see through the solution turning pink and shifting left. So we know that the reaction is endothermic based off when the hot and cold, or the heat and the cold, are added/removed, because if it is heated, it is shifting right, which is dictating that it's endothermic, and if the heat is removed, it is shifting left, as it's placed in the cold. It is shifting left, therefore meaning that it is also endothermic. For part A, we have an acetic acid/acetate equilibrium. The pH originally is a 4, which is fairly acidic. However, when sodium acetate solution, which is more basic, is added, we can see an increase in the pH to 6, which is more basic than the pH of 4. So we can see the equilibrium shifting left because the sodium acetate is reacting with the H+ ions, causing an increase of the CH3COOH, which also is making a decrease in the CH3COO-. So therefore, it is causing the reaction to have a higher pH corresponding to a more basic equilibrium solution. And then for part B, we have a chromate/dichromate equilibrium. When an acid was added, such as here, we see that the color stayed a clear bright orange because the original color was a clear bright orange color. When a base was added, such as here, the reaction changed to a clear bright yellow color. The color of the CrO4 2- is yellow, and the Cr2O7 2- ion is orange. So when a base was added, such as here, we can see that the equilibrium is shifting left because it is creating a clear bright yellow color, which is the CrO4 2-. So when the base is added, it is shifting towards the left, causing a more yellow color. However, so this is an already basic solution, when the HCl, which is an acid, was added, a more clear bright orange color was created, which shows or dictates a shift to the right because it is decreasing and increasing the CrO4 2- and increasing the Cr2O7 2-, which is calling for that orange color. The original solution has the color that it does because it is more acidic and it is containing the Cr2O7 2- ions, which again is an orange color. And then just to recap, every time an acid was added, it would shift back to the right of the clear bright orange color, and every time that a base was added, it would shift towards the left, which was a more clear bright yellow color. Thank you.